Network access control. So now that we've configured our devices and technologies that made up our architecture, we can move on to actually designing our network architecture. So design elements of the network are just as important as the devices and technologies that we use to set up this network. So when it comes to network access control, this is going to be a general term for the collective protocols, policies, and hardware that govern access on our device and network interconnections. So, network access control is going to provide an additional security layer that scans systems for conformance and allows or quarantines updates to meet policy and standards. Security professionals will deploy a network access policy according to the organization's needs based on three main elements. This is going to be authentication methods, endpoint vulnerability assessments, and network security enforcements. Typically, um, NAC's implementation NAC implementations have a few common characteristics. They're going to provide device access to the network if it can successfully pass a health check. It's going to have an assessment in this health check that's going to determine if a connection meets minimum security standards. So a NAC can either be agent based or agentless. So agent based is going to be software agents that are installed on devices that request access in order for the NAC to carry out its health checks. These agents are going to be classified either as permanent or dissolvable. A permanent one is going to stay indefinitely on that device, and a dissolvable one is going to be removed once that device is authenticated. Then we have the agentless NAC, and this is going to be used for network scanning and analysis techniques to ascertain certain health information without needing to have specific software. Demilitarized zones. Demilitarized zones. A demilitarized zone is a section of a private network that is made available for public access. It is going to be a section of a private network that is located behind a firewall or between two firewalls, and that is where your public access is going to be. A DMZ is going to enable external clients to access data on a private system, such as your web server. And however, you're not going to compromise the security of the internal network as a whole because you have that you have that firewall, right? Um, and then we have a more secure firewall in which we have a two-way firewall scheme that's going to have an external firewall which enables public clients to access a particular service, and then another internal firewall which is going to prevent them from connecting to more internal services and hosts. Network isolation. Network isolation is also known as network segregation. It's going to be the practice of keeping networks separate from one another. And this security motivation behind this is to ensure that communication between networks are more easily manageable, and that network security policies can be applied more granularly. So, one example of network isolation would be to have an air gap in which a network would be physically separated from all other networks so that a host on the other side cannot access that network through that gap, right? And so another isolation tactic besides that is going to be network segmentation. This is also known as subnetting. So segmentation is going to be the practice of dividing a network into multiple subnetworks. So in security, the purpose of this is to make sure that attackers who gain access to one segment of our network cannot easily move to another segment in our network. So the intent here is to limit the amount of damage that an attacker can actually do. So segmentation could be achieved through several means. First, we could have a physical separation of the network appliances and hosts. So maybe we create a segment for the finance department by putting all the finance workstations behind a physical switch that's connected to a port on a physical router. However, hosts in this finance segment won't be able to broadcast to other networks, which is going to help reduce the attack surface. But we could also do this with something called a VLAN. which we're going to get to a little bit later. Um, so in segmentation, we can have something like this, in which we have a finance subnet and a marketing subnet. So in this case, we have this physical separation of the both of these. The marketing department and the finance department are on their own networks. So this ensures that the inbound and outbound traffic are going to be controlled for. Then we have virtual local area networks. So this is known as a VLAN. This is a logical method of segmenting a network at the data link layer. So layer 2. So this is going to be similar to a subnet. However, the subnet is going to work at layer 3. Basically, what's going to happen here is the VLAN is going to enable an organization to group networks together even if the host is not connected to the same physical switch. So a VLAN segment can share a physical connection to a switch with another isolated VLAN segment. If the configuration of the network changes, the physical devices and cabling won't need to be configured this way. And so this is all made possible through the virtualization of network infrastructure. So the same way how virtual machines are going to make it easier to configure and deploy and manage network hosts, the VLAN can be configured to map out a typical subnet configuration, and you can even implement multiple subnets on a VLAN. So we have here a virtual LAN both on this one switch. So here we have the finance subnet and also the marketing subnet. When it comes to network security device placement, there are several devices that we are going to go over here. So first of all, we're going to deal with the aggregation switch. So the aggregation switch is going to combine multiple ports into a single link in order to enhance redundancy and increase bandwidth. So the aggregation switch can typically be placed in between switches and provide direct access to the host and the core that connects to other segments of the network together. Then we have firewalls. So a firewall is going to be usually placed at the perimeter of a network where the private network is going to be closest to a public network, such as the internet. So in the DMZ configuration, a firewall can also be placed at the edge of a DMZ, so that way it's closest to the rest of our private network. So we might have the internet followed by a firewall, followed by some server, followed by another firewall, followed by our private network. When it comes to proxies and filters, because proxies typically work with traffic that is inbound from an outbound location like the internet, they're going to be put close to the perimeter of a network. There are a lot of firewall products that also have proxy and filtering functionality as well. Then we have our load balancers. So these are going to be placed typically in the DMZ before a web server in order to handle excess traffic. So some load balancers are going to be meant for back-end traffic handling, and these are going to be placed outside the DMZ and in the private network. However, these are going to be before any dependent servers, so that way we don't overload those servers themselves. Then we have taps and sensors and monitors. So a network tap is going to create a copy of network traffic in order to forward it and monitor it like an IDS, right? So network taps are often enabled through port mirroring. And so when we place these taps, they're going to depend on what type of traffic we want to monitor. So if we want to monitor any malicious traffic from an external source, we're going to want to put these taps alongside the perimeter firewall. However, this is going to be noisy for monitoring traffic because we can get traffic that we're not really concerned with. However, if we're concerned with malicious traffic, we might have already made its way into our private network. We're going to want to place these monitoring devices with our switches, so that way we're providing our end users support. And then we have collectors and correlation engines. So this is going to placed outside of the DMZ and in private networks to pull log data from hosts. This is going to be for our seams, right? And so this way the seam isn't directly exposed to the internet, but it's able to pull all the logs that it needs. And then finally, we have our VPN concentrators. Our VPN concentrators are typically going to be placed behind a firewall and in the ZMZ next to the firewall itself. Network address translation. So this is a service that translates between different IP addressing schemes, such as being placed between a public-facing and a private-facing IP address. So in its simplest form, network address translation is going to conceal the internal IPv4 address from the public internet. So the router is going to be configured with a single public IP address, and then everyone else underneath that router. So this is your router at home, and then we have several other devices. Everything will be sent through to this router with a public-facing internet address, and these will be our local addresses, our private IPs. Software-defined networking, or SDN. This is an attempt to simplify the process of administrating a network by separating systems that control where traffic is sent from systems that actually forward the traffic to its destination. So this is going to allow our network administrators to directly program the control systems without having to focus on the forwarding systems. Network administrators are then more easily able to manage the flow of the logistics of their network and adjust traffic on the fly based on their needs. So an architecture designed around an SDN may actually provide us greatest security insight because it enables a centralized view of the network. Just think of software-defined networking as being able to actually go ahead and program the control of the network, program as in code the network, how you want it to react and move when you think of software-defined networking, and that should be enough to get you through the Security Plus test. Now we have guidelines for when it comes to securing network design elements. We should consider implementing network access control solution in order to govern how devices access the network. We want to implement a DMZ in order to separate public-facing resources from our internal ones. We want to place one firewall at the external edge and another at the internal edge for optimal security of the DMZ. We want to design the network with isolation in mind. We want to create air-gap networks that can't communicate with the larger network. We want to create subnets in order to segment hosts with a common purpose. We want to implement VLANs to stream the management of network segments. And we want to place each type of security device where it will be most effective in the logical and physical architecture of the network. So we should implement a network address translation in order to conceal any IPv4 addresses of our internal hosts from the external networks, such as the internet itself. And then we want to consider implementing software-defined networking in order to improve the network management process, and we can make changes on the fly using code in order to do that.